What's up, Inspire Vision, plus anybody I might be catching on YouTube? This is day 3 of our Accelerated Algebra I course. This course is to help us prepare for the STAAR test that is coming up in July. So, we are covering equations today that do not have like terms. We're also solving inequalities. Now, this video was done a little bit out of order. That's just because this lesson is very important to algebra, and I wanted to make sure to do it right. So, as always, it is time to learn some math. Let's tackle that STAAR test. Now, today's lesson is out of reporting category 1, TEKS 8.12. We're doing 8 guided practice questions after our lesson, and then I'm going to want you to do 9 independent practice questions on your own where you try before I cover the questions. And then finally, we're going to do 2 STAAR questions that applies what we're learning today to multiple different concepts on the STAAR test. Okay, so I teach solving equations a little bit differently than you might have from a previous teacher. I teach solving equations using these graphic organizer that you see on the screen. So using these shapes, this tells us the order that we should approach every equation, every inequality, and every systems. And what these shapes mean is our first step, we should distribute. Our second step, we should clear fractions. So this works just like PEMDAS, where the P stands for parentheses, the E stands for exponents. So our first step is to check to see if it needs to distribute. And then our second step is to see if we need to clear fractions. And then combine like terms. And then finally, we're going to set up our rectangle and triangle, and then we're going to do the opposite of the triangle next, and then do the opposite of the rectangle. So these are our final 7 steps, 8 steps that we're going to do while we solve equations. Okay, now before I teach you about all of the steps, let's just focus in and not get overwhelmed. Let's focus in on the rectangle and the triangle. So the rectangle is always going to go in front of the variable that we're solving for. So we're solving for x. It's going to be the coefficient in front of x. Now, we don't always have a triangle. While we always have a rectangle, we don't always have a triangle. But if we do have 2 things on the same side of the equation that we're solving for x or whatever variable it is, then we'll have a triangle. Okay? Now, to teach you that, let's get good at just setting this up. So we have negative 2x plus 2 equals 4. And I just want to know if we can set up where our rectangle goes. So our rectangle goes always in front of our x, always to the left. It's always its coefficient. But the key here is that we take the sign with it. So we're going to draw a rectangle around the sign as well. And then the triangle is if there's another term on the same side that x is on. So we have plus 2 on the same side x is on because x is on the left-hand side of the equal sign. So the triangle goes around the plus 2. All right, here's another example. So this time our x in the equation negative 9 equals negative 3 minus 7x. Our x is on the right-hand side of the equation. So if you ask yourself what is in front of the x, what is its coefficient, that is negative 7. So that's what gets the rectangle. Then you ask yourself, is there anything else on that same side of the equation? And your answer is yes. There's a negative 3, so that would be the triangle. Okay, next, we have the equation negative 12 equals negative x. Now, this could be tricky. In algebra, you might say that the 12 is the rectangle because that's the only number you see, but that's not true. In algebra, whenever there's a letter by itself, there's always a 1 in front of it. So if you put negative 1, because that was negative to begin with, if you put negative 1 in front of x, that is your rectangle. Okay? Now, what about this one? This time I have x plus 3 on the left-hand side of the equation, and on the right-hand side of the equation I have 45. So that means my rectangle is the 1 in front of x, because there's an imaginary 1. And then, do we have a triangle in this problem? And yes, we do. It's the plus 3. All right, so there's some examples setting it up. What happens if you have both x and y in the problem? Like this one. So we have negative 5y equals 25x minus 10. And on the second equation, we have 3y minus 9x equals negative 12. Okay, so the first equation. Whenever we have both x and y in the problem, we're always going to solve for y. So my rectangle is going to be whatever number's in front of y, its coefficient. So on the first equation, the negative 5 is the rectangle. Now, do we have anything else on the same side of the equation as this y? Because the y is on the left-hand side. And the answer is no, we don't. So no triangle in this first problem. In the second problem, we're still going to solve for y, because 99% of the time in algebra, we're always solving for y. So we ask yourself, what's in front of y? And that is the 3. So what's the triangle in this problem? Well, it's the minus 9x. That's what's weird. In the previous problems, we would only take the number. But the 9x and the negative 9x, they count as one term. So that whole term gets a triangle. We'll talk more about these problems in a few slides, and especially on day 5's video, where we focus on solving for y. Okay, now, we just spent the last few slides just setting up where the rectangle goes and where the triangle goes. Now I need to teach you what to do with those shapes, why that's so important. Now, we're always going to do the opposite of the triangle first by doing plus or minus. And then we're going to do the opposite of the rectangle by doing multiplication or division. Most of the time we're going to divide to get rid of it. And something very important, very important is we never change the sign of the rectangle when we divide. But you're always going to change the sign of the triangle, because if inside the triangle is plus 3, then we're going to do minus 3 to get rid of it. Or if inside the triangle is minus 5, we're going to do plus 5 to get rid of it. All right, let's look at our examples. So in this problem, the rectangle, because we're solving for r, is the number in front of r, which is the 2. The triangle in this problem is the minus 5. So what I just said is we always move the triangle first by doing its opposite sign. So the opposite of minus 5 is plus 5. So we're going to write plus 5 underneath the triangle and underneath the other side of the equation. We're never ever going to do it underneath the rectangle because we're trying to solve for r. So we're not going to add more numbers to where r is. No, we're going to move it to the other side of the equation. So that means right now, after we get rid of the triangle, we're going to have 2r equals 8. Then, our last step is to divide by our rectangle. So if there's a 2 in front of r, we're going to divide by 2 and take your other side and divide by it. Okay, now if that was negative 2 in front of r, we would divide both sides by negative 2. So we never change the sign of the rectangle. That's what I want you to get. So the answer to this question is 4. All right, let's look at some of the examples we've already set up. So this was our first example. We already said that the rectangle was the number in front of x, which was negative 2. The triangle is plus 2. So we're always going to move the triangle first by doing its opposite. So inside that triangle is plus 2. The opposite is minus 2, and we're going to do it to the other side of the equation where the 4 is. All right, so our next line, we're actually going to figure out what 4 minus 2 is, which is 2. And now our step looks like this. Negative 2x equals 2. So we're going to divide both sides by the number that's in front of x, which is negative 2. If we take both sides divided by negative 2, that cancels. And we're going to have x is negative 1, because 2 divided by negative 2 is negative 1. Okay? Next, we had negative 9 equals negative 3 minus 7x. We already said that the rectangle was the negative 7, the triangle is negative 3, but we need to move the triangle first by doing plus 3 on both sides of the equation. That cancels this triangle out on the right-hand side. On the left-hand side, we have negative 9 plus 3. We need to do that, so we either need to know our integer rules, or we can type this in our calculator, negative 9 plus 3. and that is negative 6. So that cancels. We're going to bring down the negative 7x. Very important. This is one of the main reasons why I want you to put a rectangle around the sign too, because we need to remember to write the sign when we go to this next step. Now, to get rid of the number in front of x, we're going to remember that to get rid of our rectangles, we divide. So we're going to divide both sides by negative 7. Keep the same sign. So negative 6 divided by negative 7. If you're using a calculator, you can type that in your calculator. Or you can remember your integer rules. Negative 6 divided by negative 7 is a positive number. So, and it doesn't reduce. So our answer is 6 over 7. Or if you're using a calculator, you're going to get a crazy decimal, and you need to hit math, enter, enter, and that gives you the same fraction because this is the reduced fraction. Okay, now going back to ones that were with y equals. Again, I'm going to talk about more of these questions on day 5, but we are solving for y in this problem. So my rectangle is the negative 5, and there's no triangle in this problem because y is on the left-hand side of the equation, and there's nothing else on the left. So the only thing I have to do here in this problem is to divide everything by negative 5. Now these are two different terms, so I need to divide both of them by negative 5. What happens on the left-hand side is the negative 5's cancel and leaving you just with y, and that's what we want. Now, 25x divided by negative 5, if you're using a calculator, you never ever divide or put x in your calculator unless you're in your y equals key. So the only thing you can type in your calculator is 25, divide by negative 5, just remember to bring down your x. So for this one, you should have gotten negative 5x. For your second term, you should remember that that minus sign means that that 10 is negative. So in your calculator, if you're using it, it's negative 10 divided by negative 5. Two negatives make a positive, so that's positive 2. Okay, so this is my answer. I know that looks a little weird, but it's because when you solve for y, we have to have our answers in the format of y equals mx plus b, which basically means you have two terms. So we no longer have a single answer or single number as our answer when we're doing equations. So that's something to keep in mind as well. Okay, the one on the right hand side, we're solving for y. So my rectangle is the 3 in front of the y. My triangle is minus 9x. So the next thing I want to do is think, okay, that triangle has a minus sign in it. So the opposite would be a plus sign. So I want to do plus, not just plus 9, but plus 9x to both sides of the equation. That will be what this cancels out on the left. That will be its opposite. Okay, now here comes one of the most important rules in math too, in algebra. When you do this right-hand side and you have negative 12 plus 9x, your answer is not negative 3. Your answer is not positive 3. Okay? Also, do not type this in your calculator because you cannot type 12 plus 9x. You don't want to type x in your calculator. What you need to do is remember that the 12, the negative 12, and the 9x are not like terms. So, and this happens whenever you solve for y, is you actually need to put these two terms side by side because they're not similar, so you can't add them together. Okay, very important. If you get that right, you're going to be doing really good in algebra because this is such an important concept in algebra. Now next, move the 3 that's in front of y by dividing by 3. So if you take both the negative 12 and divide by 3 and the 9 and divide by 3, we'll have our answer. So it'll be y. Negative 12 divided by 3 is negative 4. 9x divided by 3 is positive 3x. And this is my answer to this problem. Okay, again, I'm going to talk more about these on day 5. So day 5, we're doing a lot of solving for y. For today, we're focused on solving for x, so you can get these fundamental rules down straight. So here's two problems where we're only solving for a single variable. That's what I mean by solving for x. So here's our guided practice where we're going to do about 9 of these, and then you're going to do your independent practice questions. All right, on number 1, we have 17 equals m minus 7. If we're solving for m, we have to set up our rectangle and triangle because we don't need to worry about distributing, clearing fractions, combining like terms, or just straight a rectangle and triangle. We're going to remember that whenever we have m, it's the same as x, and there's an imaginary 1 in front of m. And that 1 is my rectangle, which means my triangle is this -7 that's on the right-hand side of the equal sign. And we're always move the triangle first, always. So that means inside the triangle is -7, its opposite is +7, so we're going to put +7 underneath the 17. And we can add these together, those are like terms, so 17 plus 7 becomes 24. The 7's cancel, and now we just have 1m. Now, whenever we divide by 1, because we want to get rid of the rectangle, our answer is always going to be the same. If we divide by +1. If we divide by -1, it's going to change our sign, but we have +1 here, so our answer is going to be 24. That's the answer to number 1. Let's take a look at number 2. Where would your rectangle go in number 2? What number is right in front of x? Hopefully you said -1.2. That would be the rectangle. Now where would your triangle go in this problem? Hopefully you said, hey, you're trying to trick me. There's no triangle in this problem. You would be right. No triangle in this problem at all because there is nothing on this left-hand side other than -1.2. So that means the only thing we have to do is divide both sides by -1.2. So when your calculator, type in 2.04 divided by -1.2, and you have your answer as -1.7. Now, if you're not happy with this answer as a decimal, know that if you're using a calculator, you can hit math, enter, enter, and it'll give you your answer as a reduced fraction, which would be -17/10. Either way works. The only time you really need to convert your decimals is when it's a repeating decimal or a decimal that doesn't end. You want it in fraction form. All right, moving on. Now, before I show you question number 3, I got to teach you the rules for clearing fractions because I'm going to show you a problem with fractions. I know. You're thinking to yourself, you love fractions. Everybody loves fractions. Okay, so here's our steps for whenever we see a fraction in the problem, which is this step, by the way. That's my attempt of drawing a fractions. So if we see fractions in the problem, the first thing we're going to do is write all of our numbers in the problem as a fraction. Then we're going to figure out what our LCM is, which is the LCD, and only multiply all of our terms, which will be all of our numerators, by that LCD. Okay, all of them. So no matter what side on the equal sign they're on, we're going to multiply. And then we're going to reduce. If we do these steps correctly, then guess what? The evil fractions will go away. So we won't have any fractions anymore. Here's what I mean by that. So on number 3, we have 3/8 plus e equals 7/8. Now this plus sign means that e is not a part of this fraction. It's its own term. So the first step is to put all terms over as a fraction. So if we do all terms as a fraction, we're going to put that e over 1. Okay? Next, we're going to figure out what the LCD is, which in this problem is going to be 8. So we're going to multiply everything in this problem by 8. All my numerators. All right, if we multiply 8 times 3, we're going to get 24, and we keep the same denominator. Then we're going to remember there's a 1 in front of e, so 8 times e is going to be 8e, and we keep the same denominator. Then we're going to multiply 8 times 7, and that is 56, and keep the same denominator. All right, next we're going to reduce. If we reduce, 24 divided by 8 is 3, 8e divided by 1 is 8e, and 56 divided by 8 is 7. Then we're going to set up our rectangle and our triangle. So our rectangle in this problem is, because we finished clearing we finished doing our fractions, we have no like terms in this problem, so we're ready for our rectangle and triangle. So our rectangle is the plus 8 in front of the e. The triangle is tricky. It's going to be the 3 that's on this left-hand side, But what's tricky about this is that triangle positive or negative? Because now we're ready to move the triangle. That triangle has an understood plus in front of it, so we need to subtract 3 on both sides. If we subtract 3 on both sides, this will cancel, leaving me with 8e, and then 7 minus 3 is 4. Now we divide by what's in front of e on both sides. So 4 divided by 8 gives us 0.5 or 1/2. So that's the answer to number 3. All right, number 4. Number 4, I meant to take this off the video, so I apologize because we already did that question. All right, moving on. So that was a problem with fractions. Now I'm going to show you a problem with a very simple inequality. With inequalities, remember that this symbol means less than. This symbol that has a line under it means less than or equal to. And we're worried about shading more on day 6. This symbol is greater than, and this symbol is greater than or equal to. Now the way that you know the difference between less than and greater than is if you hold up your hand and try to make it the sign. If it makes an L with your hand, then you know it's less than. And you're looking for all the answers that are less than whatever that number is. So if it was less than 5, it would be everything 4 and below. 4, 3, and 2. Anything less than that. All right, this is what we need to focus on. We need to focus on when our symbol flips. So we're talking about if the less than flips to a greater than. It flips for if we have a negative in our rectangle when we set up our rectangle and triangle. That means that we would be dividing by a negative number or multiplying by a negative number. Reason number 2, when we flip. When we have our equations, we always want x on the left side. So if or whatever we're solving for. So if it happens to be on the right side, that's what we don't want. We want it on the left side. So we would flip it over to be on the left side and flip the symbol too. All right, let's take a look at our very easy inequality today. It's this. So in order to solve this equation, we would set up our rectangle and our triangle. So our rectangle would be the 1 that's in front of x. The triangle would be the plus 10. Always move the triangle by doing minus 10 on both sides of the equation. And these are not like terms, so 7 minus 10 becomes negative 3. Wow, PowerPoint full of mistakes today. All right, then we need to divide by the number that's in front of x. So if we take 1 divided by 1 on both sides, it does not change anything. But before I write my next step, I want to say, do we flip the symbol? Remember, there's only 2 reasons why we flip. Is x on the right side? No, x is on the left side. That's good. Did we divide by a negative number? Was there a negative in our rectangle? No, there wasn't. So that means my answer is x is less than 3. Okay, so that would be anything less than negative 3. So looking at my answer choices, all the numbers that are less than negative 3, we can't include negative 3 because it doesn't have a bar under it. So no bar. Let me erase that so somebody looking at this doesn't get confused. We would want all the answers that are less than negative 3, which would be C. Okay, a little bit more guided practice. So number 5, we have 1/6x minus 2/3 equals negative 12. Now, we have fractions in this problem, so we would want to clear these fractions by trying to first trying to make everything in the fraction, or make everything in the problem a fraction. Now, just because this x is right next to the 1/6 doesn't mean that they're separate. There's not a plus or minus separating this x. So that x actually goes into the numerator with the 1. If a 1, I could rewrite the entire equation and say 1x over 6 minus 2/3 equals negative 1 over 2. The next thing I have to do is figure out what the LCD is. Now, it's always easier to start with your biggest number, and LCD means you're thinking, okay, 12 times 1 is 12, 12 times 2 is 24, And 12 times 3 would be 36. Then if I take my 6, I'm doing the same thing. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. You're looking for what LCD stands for is the lowest common multiple, which is the lowest common number that they have in common. And that would be the 12. So all my numerators need to be multiplied by 12. If I do that, 12 times 1x is 12x. Put that over 6. Then 12 times negative 2, just write it as minus, that would be 24 over 3. And then 12 times 1 is 12 over 12. Always keep your same denominator. Then if I reduce, I'm dividing. So 12x divided by 6 is 2x. 24 divided by 3 is 8. Negative 12 divided by 12 is negative 1. Now I'm ready for my rectangle and triangle. So my rectangle is the 2. The triangle is negative 8. So I'm going to do plus 8 on both sides of my equal sign. Negative 1 plus 8 is positive 7. Divide next, because I'm trying to get rid of the rectangle. I'm going to divide by 2. And my answer is 3.5, or math enter, convert that to a reduced fraction, and that is 7 over 2. All right, number 6, you see these parentheses. These parentheses means I need to do this first step, which is distribute. I'm going to distribute first. I'm going to take the sign with this 5 when I multiply it by 6n. So negative 5 times 6n becomes negative 30n. Negative 5 times positive 6 would be negative 30. Now, for some reason, this was a negative instead of a plus sign, or a minus instead of a plus sign. Then it would be a negative times a negative, and this would turn into plus. But since it's plus, a negative times a positive is a negative. All right, now I'm ready for my rectangle and triangle. So the number in front of n is my rectangle, which would be the negative 30. Triangle is this minus 30. Do the opposite of the triangle next by doing plus 30 on both sides. 30 plus 30 is 60. Bring down the negative 30 in. Then divide. Keep the same sign. Don't change that sign when you divide. 60 divided by negative 30 is negative 2. All right. Next. These are my last guided practice questions. Then you're going to start your independent practice. On number 7, we're solving for h. So the number in front of h is 2.55. I have something else on that same side as h, which is plus 71.59. Then I want to move the triangle first by subtracting 71.59 on both sides. If you type this in your calculator or do the math by hand, you're going to get 61.2, and then you're going to bring down 2.55h. And you divide both sides by 2.55, and you're going to get the answer of 24. Hopefully that makes sense. So don't get scared by these decimals. All right, number 8, you have a fraction. So you're going to want to make everything a fraction. The only thing that's not a fraction right now is 34. Then you want your LCD. Always start with your biggest number. So think about 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. Now we also have 1 to worry about, but 1 times anything is going to be our answer. So if you just look at 3 and 7, our LCD, the lowest number that they have in common is 21. So we would multiply everything times 21. So 21 times x and 21 times 2x. This is going to give you 21x over 7, 42x over 3, and you're going to get 714 when you multiply 21 times 34. Always keep your same denominator. Then we're going to divide, and we're going to get 3x plus 14x equals 714. Now, I did say that we wouldn't have like terms today, but this is seeing if you remember from day 1 when we were combining like terms. If you remember, these like terms on the same side of the equation, so we're just going to add them together. So 3x plus 14x, we need to do that before we do our rectangle and triangle. Now, this is going to come up all the time, so that's why I kind of threw this in here. So when you always distribute, then you clear your fractions, and then you combine your like terms before you do your rectangle and triangle, which is what I need to do here. So 3x plus 14x is going to become 17x. Then my rectangle is the number in front of x, which is 17. And there is no triangle in this problem, so I need to divide both sides by 17. And I should have done this to signal that this is my rectangle. No triangle in this problem. Divide both sides by 17. So 714 divided by 17 is 42. All right, now comes the time to see if you can do this on your own. So here are these 3 questions. I want you to pause the video, see if you can answer these questions. And I'm going to cover the answers a little bit later. All right, here's the next 3 questions. Pause the video, see if you can answer these questions. And here's the last 4 questions. Pause the video and see if you can answer these questions. Okay, for time's sake, I have to cover these answers a little fast, and you can see that I have a little error here with my animation. So I'm going to cover the answers, and hopefully you did the same steps, or hopefully through me explaining the steps you understand the answers. So the first question, we would want to set up our rectangle and our triangle. The rectangle is 5, the triangle is -4, so we're going to do +4 on both sides. If we do +4 with the 26, we're going to get 5x equals 30, and then we're going to divide as our last step. Okay, so 30 divided by 5 becomes 6. So your answer should have been A. On number 2, we're going to want to set up our rectangle to be the 1 that's in front of x, our triangle to be the -8. We always move the triangle next by doing +8 on both sides of the equation. So -5 plus 8, that becomes 3. Now if we divide both sides by +1, that's not going to change anything, so our answer is 3. On number 3, we have a fraction. We're going to remember that x is not separated by a plus or minus, so that x really goes into the numerator. So that's going to be 1x over 4, and then we're going to write -6 over 1, because next we're going to want to clear our fraction by multiplying everything times 4. That's our LCD. If we multiply 1x times 4, we're going to get 4x over 4, because we don't multiply the denominator, only in the numerator. And then 4 times -6 is -24. We reduce this, and that's going to give us a 1x. And on the right side of the equation, we have -24 divided by, or -24. Then to get rid of the 1, we divide both sides by a +1. So your answer is still -24. Number 4, you see something interesting in math. You see a minus in the parentheses of minus. Try to remember that you can never have a minus in math. It just turns into a plus. But if you don't remember that, think of this as a -1 times a -1. A -1 times a -1 turns into a +1. So this turns it into a +31. Now the next we're going to do is set up our rectangle triangle. And we always move the triangle next by doing its opposite. So -31 on both sides of the equation. So 15 minus 31 becomes -16. And if we divide by -16 by 1, we still have -16. Only if that was a -1 in our rectangle, that would change our answer. Number 5, we have a fraction. So we're going to put the 4 over 1. Our LCD is 8.4. So we're going to multiply both the numerators by 8.4. So this is going to be 33.6 on the left side. And then 8.4 divided by 8.4z on the right side. The 8.4's cancel. And the 33.6 over 1 still is 33.6. So that's our answer, D. Number 6, we're going to set up our rectangle to be 1, our triangle to be +7. We're going to subtract 7 on both sides of the equation. So we're going to get 1x is less than or equal to -2. Then we're going to remember when we divide by 1, do I flip? The answer is no, and that means that our answer is x is less than or equal to -2, which means it has to include -2 in the answer and all the numbers smaller than -2. Number 7, we have 5/9 y. We're going to remember to put the y with the 5 and put everything else as a fraction to clear our fraction. Then we're going to multiply all our numerators times 9 to be 45y over 9 minus 36 over 1 equals 54 over 1. We're going to divide our fractions, and that's going to be 5y minus 36 equals 54. We're going to set up our rectangle triangle now because we're solving the equation. So we're going to do plus 36 next to get rid of our triangle, which is 90, and then divide both numbers by 5. So 90 divided by 5 is 18. Number 8, we only have a rectangle, so we're going to divide both numbers by negative 2.8, which gives us a positive 0.01. Number 9, we're going to set up our rectangle and triangle. Our rectangle is negative 3, our triangle is negative 15, or minus 15. So the first thing we're going to do is move the triangle by doing plus 15 to both numbers, and then we have our integer rule of negative 12 plus 15. That becomes positive 3. Then we're going to divide by negative 3 on both sides because there was a negative 3 to begin with, and 3 divided by negative 3 gives us a negative 1. Okay, our last question for independent practice, then we're going to do 2 star questions really quickly. I know this video is getting a little long. So we have a 1 in front of x, and our triangle is 6. So we're going to subtract 6 on both sides, and we're going to get 5. Now we're going to remember that if I'm dividing by 1, I still don't flip, and my x is on the left-hand side. So then the symbol is greater than, but it's not greater than or equal to, so I can't have my number equal to 5, only the number's bigger than 5, which is b. Okay, so on 49, very quickly, just to show you that we're going to use these skills coming up later on, this is an inequality very similar to what we just did. But this time we're solving for y. And I talk more about these problems on day 6. So if we solve for y, my rectangle is the plus 7. My triangle is this entire term minus 2x. So I would move the triangle first by doing its opposite, which is it's not just plus 2, it's plus 2x to the 112 that's on the right hand side. Now, when we do 112 plus 2x, we have to remember that these are not like terms. I'm going to say this a lot on day 5 and day 6 video. So we're going to put them side by side. Then we're going to divide both of these terms by 7. When we divide both of these terms by 7, we're going to ask ourselves, do I need to flip the symbol? And none of these reasons happened. There was not a negative in my rectangle, and since we're solving for y in this case, not x, x is on the left-hand side, which is what we wanted. So no. So here's what my answer is. 112 divided by 7 is 16. 2 divided by 7 is a repeating decimal, so we write it as 2/7 x. Now, this is something we're going to talk about a lot on day 5, day 6. Once you have an equation solved for y, you put in your y equals key. You try to graph this one, but you're not going to see it because the number's too big. But if you zoom out, you hit zoom 3, enter, you will see what the picture looks like. And then you remember that this symbol is shaded below and has a solid line. So my answer is going to be C. Now, if you did hit zoom 3, enter to see your picture, make sure you hit zoom 6 to fix your graph so it's back to normal for your next question. All right, last question for today. This is a system. We do systems more on day 9, but for systems, we want to make sure we solve for y. So our first equation is not solved for y. These are our steps that we do for systems. But in order to solve for y, I would put my rectangle in front of y, which is the 2. And since there's plus 14 on that side, we're going to put the triangle around the plus 14. Not around the 3x, because the 3x is on the left-hand side. We only want the terms that are on both the right-hand side of the equation. That's our rectangle and triangle. So we're going to do minus 14 next. We're going to remember that 3x minus 14 are not like terms, so put them side by side. And then divide both of them by 2. Once we divide both by 2, we have 3/2 x, or 1.5x, minus 7. We're going to put them both into our y equals key like this. We're going to graph it. And again, I talk more about this on day 9, how to solve systems, but our answer would be A, because that is the x value. Okay, I hope you enjoyed today's video. I know I covered a lot of concepts pretty fast. I reinforce these concepts throughout other day lessons, so stay tuned for those lessons.